Geometrical interpretations of vector product. Suppose the two vectors A arrow and B arrow are represented in magnitude and direction by the two sides of by the two adjacent sides of a parallelogram OPRQ. That means the sides OP stands for the vector A in magnitude and direction, and the sides OQ stands for the vector B in magnitude and direction. Okay. If this angle POQ, let's say it is theta, then I drop a perpendicular line. Let's say this is QN. Okay, right? Don't get confused. Okay, this is my A vector, which is magnitude is OP, and it is directed in this way. Now I drop a perpendicular QN perpendicular to OP. Fine. Next, what is the magnitude of A cross B? Magnitude of A arrow cross B arrow is equals to modulus A arrow cross B arrow, or AB sine theta. This we have seen in the previous video. Again, what is vector A? Vector A, the magnitude of vector A is the line OP. What is magnitude of vector B? It is equals to the line OQ, and then sine theta. Now this OQ sine theta is equals to which sides? Okay, let us see that. See, this is my right angle triangle O and Q. So when you take sine theta in this right angle triangle, we know sine is equals to perpendicular by hypotenuse. So your perpendicular is QN and your hypotenuse is OB. Or sine theta is equals to QN upon, sorry, this is OQ, right? Upon OQ, but OQ is equals to B. So QN is equals to how much? B. QN is equals to B sine theta. Okay, so instead of this QN, I will write B sine theta. B sine theta. Okay, okay. So this is OP, and this OP, okay, this is fine. And instead of OQ sine theta, what is this OQ sine theta? This OQ sine theta, okay, if you don't substitute the value of OQ, that means this OQ remains here. So OQ will remain here, isn't it? So this OQ sine theta is equals to QN, isn't it? Now, what is OP? OP is the base. What is QN? QN is the perpendicular distance between the parallel sides of a parallelogram. So base into perpendicular distance is what? Area of parallelogram. Which parallelogram? OPQR. So therefore, we conclude that the magnitude of the vector product of two vectors is equals to the area of a parallelogram in which the two vectors are represented by the two adjacent sides of a parallelogram. Okay, fine. Next, also we can see here that the magnitude of the vector product of the two vectors is equals to, okay, if this is my equation 1, then equation 1 says the magnitude is equals to OP times QN. Now, if I multiply and divide this, the right hand side of equation 1, multiply and divide by 2, then you'll get the same thing, isn't it? Okay. Or, now this half OP QN, half is base, QN is height. So if you join this line QP here, then half OP is the base, QN is the height. So half into base into height give you what? Area of triangle. So magnitude of the cross product A cross B is equals to 2 times the area of triangle OPQ. Okay, so this is your equation 2. So either equation 1 or equation 2 give you the magnitudes of the vector product. So this we obtain it diametrically by considering the two vectors represented by the two adjacent sides of a parallelogram. Okay, so please remember the magnitude of vector product is either equals to the area of a parallelogram or is equals to twice the area of a triangle.